So students, now let us discuss Smith chart. So whatever formulas we have studied, using those formulas we can find D maximum, D minimum, or otherwise reflection coefficient, standing wave ratio, etc. They are the formulas. Then what is Smith chart? Smith chart is also this is a diagrammatical calculation of like SWR, etc., etc. That means ultimately Smith chart is drawn from the equations which we have studied till now. अभी तक हम लोग जो equations पढ़ लिया वही equations से ये स्मिथ चार्ट भी ड्रा करने वाला है हम लोग. सो ये स्मिथ चार्ट होता क्या है? स्मिथ चार्ट इज ए प्लॉट मतलब डायग्राम है. प्लॉट ऑफ नॉर्मलाइज्ड impedance. You will understand normalized impedance means small z. Okay, that is nothing but capital Z by Z naught. Normalized impedance or otherwise normalized admittance, that is nothing but small y, that is 1 by small z actually. That is reciprocal of that one. So is a plot of normalized impedance or otherwise normalized admittance on the complex reflection coefficient, that is nothing but gamma is equal to gamma real plus j gamma imaginary on the complex reflection coefficient within a unit circle. So अभी तक आपको कुछ भी समझ में नहीं आया होगा, मैं समझा दूंगा, कोई टेंशन मत लीजिए आप लोग. Till now you did not understand this, so no problem, I will explain that one, don't worry about that. Now one by one, before going to Smith chart, let us discuss the basics required to draw the Smith chart. First basic na, reflection coefficient that is gamma is in general reflection coefficient is in general complex. It is complex, that means having real and imaginary parts. So that is why gamma is equal to gamma real plus j gamma imaginary, because it is a complex number. So every time it is difficult to write this gamma real imaginary big na. So simply I will put gamma r plus j gamma I. Gamma r means real part of reflection coefficient and gamma I means imaginary part of reflection coefficient. So already we have studied that from this na mod gamma means what? What is the magnitude of complex number? So root of real part square plus imaginary part square. Okay. Now range of gamma is, we have studied this na, 0 less than or equal to mod gamma less than or equal to 1. We have studied this one already. So the least value is 0 and highest value is 1. So 0 less than or equal to mod gamma is actually what shall I do? I can, okay, no problem. I will do like this, students. Let it be like that. So what is the least value of mod gamma? That is 0. What is the highest value of mod gamma? That is 1. Next, the least value of mod gamma is 0. That implies what is mod gamma from this? Mod gamma is nothing but root of gamma r square plus gamma I square is equal to 0. From this we got gamma r square plus gamma I square 0. Let us say this is equation 1. It is like x square plus y square is equal to 0. So this is a circle equation. This is a circle equation on xy plane with center 0, 0 and radius 0. So any circle of radius 0 means that is a point actually. That is a point. So in this way, this equation 1 is a circle of radius 0 with center 0, 0 on gamma r and gamma I plane actually. So equation 1 is a circle on gamma r comma gamma I plane with center 0, 0 radius 0. So it is a point. That is a point actually. I will draw here after discussing the maximum also. Okay. The maximum value of mod gamma is equal to 1. So here mod gamma is this one. That means root of gamma r square plus gamma I square is equal to 1. So ultimately gamma r square plus gamma I square is equal to 1 you get. So this one is equation number 2. So equation 2 is a circle equation. No, I am not writing here. So equation 2 is circle equation on the gamma r and gamma I plane with center 0, 0 and radius 1. So if radius is 1, that is called unit circle or otherwise unity circle. Unity means radius is 1. So equation 2 I am drawing here. So let us take this as a x-axis, this as a y-axis, this is x-axis, this is y-axis, then that is called xy plane. Now let us take this is a gamma r axis, this gamma I axis, then automatically this is minus gamma r axis, this is minus gamma I axis, this is center. Now this one, this equation 1 is nothing but point here because radius 0 circle means that is point. So this circle is gamma r square plus gamma I square is equal to 0 circle. Now this circle is gamma r square plus gamma I square is 1 circle. So you draw a circle here. So here it is 1, here it is 1, here also 1, here also 1. So this is the, what is this, gamma r square plus gamma I square is equal to 1. So unity circle or otherwise unit circle. Okay. So to understand this Smith chart, we are discussing in the basic student. So this is one basic point. Okay. Now this is called unity circle. So Smith chart will be inside this unity circle. That is what written here. On the Smith chart is a plot on the complex reflection coefficient. On the complex reflection coefficient plane student here, that is missing here. Complex reflection coefficient plane within a unity circle or otherwise unit circle, both are same, is a plot of impedance on the complex reflection coefficient plane. This is that complex reflection coefficient plane within a unit circle or otherwise unity circle, both are same. Unit circle or otherwise unity circle means radius is 1. I will put here radius is 1 here, this side also 1, here also 1, here also 1 magnitude. Magnitude is 1 every side, but here this value is called as minus 1 and this value is called as minus 1. Magnitude is 1 actually. Okay. Now next point I am going to discuss. On the transmission line, impedance that is Z is also complex. So that Z has what do you say, real part that is called resistance, imaginary part that is called um, reactance. So this is resistance, this is reactance. I am not writing, if you want you can write. Okay, everything I can't write, students, because board will be filled up. भर जाएगा बोर्ड, बिना कुछ बता के भर जाएगा, सब कुछ लिखेंगे तो. So students, Z is complex impedance, R is resistance, and this X is actually reactance. This is complex. Now normalized impedance is normalized impedance, small z symbol is small z is equal to capital Z divided by Z naught. Already you know that small z is equal to capital Z is R plus Jx. Of course plus or minus, now we are taking plus, don't bother about that. So divide by Z naught, that implies small z is equal to capital R by Z naught and plus J capital X by Z naught. We are taking this capital R by Z naught as small r and plus J into capital X by this is small r, capital X by Z naught is a capital X by Z naught as small x we are taking. I will write the names now. Small r is equal to capital R by Z naught. This is called normalized. So this is resistance. Resistance by Z naught is called normalized resistance. Can you tell me what is small x? That is capital X by Z naught. Capital X is actually reactance. And divide reactance with Z naught, that is called as normalized reactance. Okay. Now, what is small z? Small z is equal to impedance by Z naught, that is called normalized impedance. Okay. Similarly, normalized admittance means that is nothing but 1 by small z. So that is normalized admittance. If you are drawing normalized impedance plot means automatically in that normalized admittance plot also will be there. Okay. Next question I am asking. Next question, students. What is the range of resistance? Range. Resistance range is 0 to infinity, short circuit, open circuit. Then automatically what is the range of this one? That is also 0 to infinity, because small r is equal to normalized resistance, that is now small r is equal to capital R by Z naught. If capital R 0, then that is also 0. If capital R infinity, that is also infinity. So that is also 0 to infinity. Now what is the range of capital X? For inductive it goes from 0 to plus infinity, and for capacitive it goes to 0 to minus infinity. So overall minus infinity to plus infinity it goes. So that small x range also, here small x is capital X by Z naught, that is also minus infinity to plus infinity. Divide infinity, minus infinity to plus infinity with Z naught, then you get same thing. If the resistance range is 0 to infinity, you divide them with Z naught, you get a range of smaller, that is also 0 to infinity. That is next point. Okay. Now in the beginning classes, I have done this derivation ZL is equal to Z naught into 1 plus gamma L by 1 minus gamma L. I have derived, students. This is nothing but gamma L is equal to ZL minus Z naught by ZL plus Z naught formula, only this one. I have derived this. Now I am telling some one point, important point, you keep observing carefully. In this formula, Z naught multiplied with 1 plus reflection coefficient at load I will take here. Here reflection coefficient at load I will take, then I will get impedance at load. For example, on this transmission line, this is ZL, and reflection coefficient at load I will take in this formula, I will get impedance at load. In the same formula, this is D0, then at D distance, reflection coefficient is gamma D. Then in the same formula, Z naught into 1 plus, if I take reflection coefficient at D distance on the transmission line in this formula, if I take reflection coefficient at D distance, then automatically I get impedance at D distance I will get. Impedance at D distance I will get. So, this impedance at D distance on the transmission line from load is equal to Z naught into 1 plus reflection coefficient at D distance from load divided by 1 minus reflection coefficient at D distance from load. So, we are not going to put these suffixes ये D, D ऐसा नहीं रखेंगे. So, this is generalized equation. So, in general, on the transmission line, impedance of the transmission line at any distance is equal to Z naught into 1 plus reflection coefficient on the transmission line at that distance. So, सब बच्चे लोग once again मैं बोल रहा हूँ आपको, जिस डिस्टेंस में आप रिफ्लेक्शन कोएफिशिएंट लेंगे उस डिस्टेंस में इंपेडेंस आ जाएगा. लोड में रिफ्लेक्शन कोएफिशिएंट लेंगे, लोड इंपेडेंस आ जाएगा. अगर डी डिस्टेंस में रिफ्लेक्शन कोएफिशिएंट लेंगे, वो डी डिस्टेंस में इंपेडेंस आ जाएगा. सो उसको ऐसा लिखेंगे हम, कोई एक जगह में रिफ्लेक्शन कोएफिशिएंट लिया है और उसको गामा करके बुलाया, वही डिस्टेंस में इंपेडेंस आएगा ट्रांसमिशन लाइन का, उसको जेड करके बुलाया हम लोग. इतना एक्सप्लेन नहीं करता है टेक्स्ट बुक में, सिंपली इधर से शुरू कर देता है, वो कुछ नहीं बोलता है. जेड इज इक्वल टू जेड नॉट 1 प्लस गामा बाई 1 माइनस गामा बोल के फिर इधर से चालू हो जाता है स्मिथ चार्ट का डिस्कशन. ये सब कुछ भी नहीं बोलता है अभी. सो अभी हम लोग इधर से शुरू करने वाला है स्मिथ चार्ट ड्राइंग. ये सब बेसिक्स है उसका रिलेटेड. ठीक है. स्मिथ चार्ट उतना इंपॉर्टेंट नहीं है एग्जाम के लिए, क्योंकि ये प्रैक्टिकल है. लाइक इसरो वाला, DRDO वाला इसको यूज करता रहता है बिना कैलकुलेशन को. इफ सो मेनी times if you want to change the design, then Smith chart is used. For 1 or 2 times calculation, we will use all the formulas only. Now let us continue the discussion. Now students, from this Z, the impedance of the transmission line divided by Z naught is equal to 1 plus gamma by 1 minus gamma. So what is this actually? This is small z is equal to 1 plus gamma divided by 1 minus gamma. So what is small z? Small z is nothing but normalized impedance, that is small r plus jx is equal to 1 plus what is gamma? At the beginning I wrote gamma is nothing but gamma imaginary plus j gamma. No, gamma has it is a complex real and imaginary. So divided by 1 minus gamma, that is gamma real plus j gamma imaginary. Now jx is equal to 1 plus gamma real plus j into gamma imaginary divided by 1 minus gamma real and minus j gamma imaginary. Right now here for both of them minus is there. Now r plus jx is equal to 1 plus gamma real j gamma imaginary divided by 1 minus gamma real minus j gamma imaginary. Here in numerator and denominator 1 minus gamma real plus opposite of this one, j gamma I, you take 1 minus gamma real plus j gamma imaginary, you take, students. So that we can here comes real, so that we can separate real and imaginary from this equation. Okay, shall I give name to this? Equation 1, equation 2 I will give. Okay, I will write like this. Equate real and imaginary parts in equation 2, then we get small r is equal to this side real part. This side how you get real part, student? Anyway, this is 1 minus gamma r, this is a minus b multiplied with a plus b formula, this is so denominator side 1 minus gamma r whole square, 1 minus gamma r whole square, then minus b square means j into j square, j square is minus 1, minus into minus plus gamma I square, so plus gamma I square you get in denominator, so this is real anyway, denominator. Okay, minus j square gamma I square, j square is minus 1, minus into minus plus gamma I square you get. Now in numerator if you want real, real into real plus imaginary into imaginary gives real part only. So real into real is 1 plus gamma into 1 minus gamma r is 1 a square minus b square formula, that is 1 minus gamma r square. 1 minus gamma into 1 plus gamma, so 1 square minus gamma r square. Next, imaginary into imaginary, that is j into j square minus 1, so minus gamma I square you get. Okay, so this is the both sides, that side real part or this side real part is this one. Let us say equation number 3. Now this side imaginary part is x. Now this side imaginary part means denominator you get this one only, 1 minus gamma r whole square plus gamma I square, gamma I square. Here to get imaginary, real into imaginary and imaginary into real gives imaginary, so this is real, multiply with this imaginary, so this is real, this is imaginary, so you multiply them, you get gamma I, then gamma I into this one plus gamma r gamma I, then here this is imaginary, this side real, so imaginary real, gamma I into this one plus gamma I and minus of gamma I gamma r. Okay, so equation number 2, that is then this is equation number 3, students. So that was the 2 was there, equation number 3. Okay, this is equation number 4, this is equation number 5, so equation 3 here. Okay, now you cross multiply this one. After cross multiplying this one by 1 is there, then you adjust that equation. Now equation 4 becomes like this, gamma r minus of r by 1 plus r, gamma r minus r by 1 plus r whole square plus gamma I square is equal to 1 by 1 plus r square. This is equation number 6. Now you know what is this? This is like x minus a whole square plus y minus 0 whole square is equal to some radius square, this is. So this is circle equation. This is circle equation on gamma r. 1 minute, student. Yeah, this is circle equation on gamma r and gamma I plane. So gamma r and gamma I plane. Radius is 1 by 1 plus r. Now you know this smaller value changes from 0 to infinity. For example, you put smaller 0, then you get one circle. Put smaller is equal to 1, you get second circle. You put smaller is equal to 3, you get third circle. In this way, you can put infinity values to smaller, then you get infinity number of circles. They are called family. Family means so many are there. So they are called family of circles. How you get each circle? By putting smaller 0, by putting smaller 1, 2 like that. For example, put smaller is equal to 1, you get one circle. What is 1? Smaller is equal to 1 means this 1 is called constant. So that is why that is called constant R circles. So you get a family of constant R circles. There they are. So equation 6 is equation 6 gives family of constant R circles on gamma R comma gamma I plane. Now you know what is gamma R comma gamma I plane. That is gamma plane. That gamma R and gamma I gives complex reflection coefficient. That is why the name of that plane is complex reflection coefficient plane. That is called as. So students, equation 5, if you do mathematics cross multiply, equation 5 becomes gamma R minus 1 whole square plus gamma I minus 1 by x whole square is equal to 1 by x whole square you get. So this one equation 7. Similarly here, this is also circle equation on gamma R and gamma I plane with center 1 comma 1 by x and radius 1 by x. So here x value varies from minus infinity to plus infinity. So in this way infinity circles are there. Each circle you get by taking x value 1 like that, 2, 1 by 2 like that. This is constant. So that is why they are called family of constant x circles. So with center gamma I plane with center, I will write center also, r by 1 plus r comma 0, okay, and radius 1 by 1 plus r. Students, this is objective question. ये है ऑब्जेक्टिव क्वेश्चन है. एक्चुअली एग्जाम में स्मिथ चार्ट तो नहीं दे सकता है जैसे बीटेक में दे रहा है वैसा, लेकिन ऐसा चीज पूछता रहता है. ये है ऑब्जेक्टिव क्वेश्चन है ये. ठीक है. सेंटर क्या होता है? कांस्टेंट आर सर्किल्स को r by 1 plus r comma 0 एंड रेडियस 1 by 1 plus r. ये तो ऑब्जेक्टिव क्वेश्चन है. इसको डब्बा में रखो. आई विल पुट दिस इन द बॉक्स. ये तो ऑब्जेक्टिव क्वेश्चन है, पूछता रहता है. So equation 7 gives a family of constant x, that means constant reactance circles. This is constant resistance circles or otherwise constant reactance circles. So simply they write constant x circles on gamma r comma gamma I plane, that is also called as complex reflection coefficient plane on gamma r comma gamma I plane. This is also called as a complex because gamma is equal to gamma r plus gamma I j gamma I. So gamma r gamma I plane means that is gamma plane only. It is called as a complex reflection coefficient plane. Okay. So gamma r gamma I plane is also called as complex reflection coefficient plane with center 1 comma 1 by x and radius 1 by x. So you put this also in the box. This is one objective question. आप लोग पूछेंगे सर ये याद रखना है करके, वो जरूरत नहीं है. ये स्टेटमेंट याद रखेंगे ना, सेंटर 1 comma 1 by x and 1 by x. automatically it is like a circle equation. You can write 1 comma 1 by x, and 1 by x is the, you can you remember this statement, automatically you can write this one. So what is Smith chart? You take the gamma r and gamma I and minus gamma I minus gamma r here. Then the biggest circle is unity circle, and inside that unity circle you draw this what do you say, constant r circles. Then they come like this, this one, this one, this one, they will come like this. I will draw them, and you draw them also. then वो लोग ऐसा आएगा, ऐसा 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 जाएगा. सो ये अभी इसको निकालना है, यूनिट सर्किल के बाहर जो भी आया उसको निकालना है. यही है स्मिथ चार्ट. स्मिथ चार्ट इज सुपर इम्पोजिशन ऑफ कांस्टेंट आर सर्किल्स. सुपर इम्पोजिशन मतलब एक के ऊपर एक ड्रा करना. सुपर इम्पोजिशन ऑफ कांस्टेंट आर सर्किल्स एंड कांस्टेंट एक्स सर्किल्स within unit circle on gamma r and gamma I plane. So how you got these equations, my dear students? How you got these equations? How you got these equations? See here, these equations coming back. Stop here. What is this? Normalized impedance. That means these are the plots of normalized impedance only. Now you read the statement, you can understand. Smith chart is a plot of normalized impedance, automatically that is normalized impedance, on the complex reflection coefficient plane within a unit circle. So that is the Smith chart. Now we are going to draw that one. So students, now let us draw the constant R circles. Okay, constant R circles. So what is the equation? Constant R circles have center. Already we have written there. R divided by 1 plus R. R divided by 1 plus R comma 0 is the center. Have center this much and radius. And radius is 1 by 1 plus R. So now let us take here R values, and the center is here. R divided by 1 plus R comma 0, and the radius 1 by 1 plus R. So here students, actually this is gamma I, and I will write like this. No, this is gamma R first one, comma gamma I second one. Gamma R comma gamma I. Now let us take R range from 0 to infinity, R0. Here a few values you take. R is equal to half, R is equal to 1 you take, then dash dash dash. Last one you take R is equal to infinity. R is equal to 0 you take 0 by 1 plus 0. 0 comma 0 is the center and 1 is the radius. R is equal to half you take half by 1 plus half. So that is half divided by 3 by 2. So 1 by 3 comma 0. Next you put here half. So you get 2 by 3. So put R is equal to 1. Then 1 by 2 comma 0. Put R is equal to 1. So 1 by 2. R is equal to infinity you put 1 by infinity 0. Now Here R infinity means infinity by infinity not defined. So you take infinity bottom side, then RR cancel. So 1 divided by 1 by R plus 1. You put R infinity. I am telling you that R divided by 1 plus R. So R divided by R, 1 by R plus 1 cancel. So again you put infinity. So ultimately you get 1 by 1. So this value is 1 comma 0 students. Now let us draw the, so this one is gamma R, this one is gamma I, this is minus gamma I, this is minus gamma R. Okay, this is actually constant, no students, this is a unit circle. Okay, this is unit circle. So approximately done. Here this is a gamma R square plus gamma I square is equal to 1. So that is a unit circle, or otherwise unity circle, doesn't matter, unit circle on the complex reflection coefficient plane. Now let us draw one by one. The first R is equal to 0 circle is center 0 0, radius is 1, that means this one only, that one. So this is actually, this circle is R is equal to 0 circle, R is equal to 0 circle. Okay, can you tell me on this circle at any location what is R value? Can you tell me students? 0. So this location what is R value? Can you tell me? At this location, at this location R is equal to 0. That is going to become short circuit point, resistance 0, na? We will see that. Short circuit means resistance is 0. PSC, P suffix SC, P means point, SC means short circuit, that is short circuit point, we will see that. Next, you see this one, R is equal to half, na? You put 1 by 3 comma 0 is the center, 2 by 3 is the radius. So from here to here distance is, you know how much, student? This is 1. You divide this into 3 parts. 3 parts approximately I am dividing into 3 parts. Part 1, part 2, part 3. So definitely this is 1 by 3. It is 0. It is 1 by 3. It is 2 by 3. And this is 3 by 3. 3 by 3 means what do you say? 1. I divided this one length 3 parts. So 1 by 3, 1 by 3, 1 by 3. Now center is 1 by 3 comma 0. So that means this is gamma R comma gamma I value. Gamma R is 1 by 3. That means gamma R is 1 by 3. And gamma I is equal to 0. Gamma I 0 means this axis only. So this is 1 by 3 comma 0 only. That is the center. Then radius is 2 by 3. So here you can see this is 2 by 3 is there. And this side 1 by 3 here and 1 by 3. This is 2 by 3. This is also 2 by 3. So this is center. Radius should be 2 by 3. So that means this is that one. थोड़ा सा नीचे ज़्यादा गया, कोई परेशान मत हो जाओ. So this is actually, what do you say, R is equal to half circle. R is equal to half circle, that is. R is equal to half. Next. Now I am removing them. Next one. R is equal to 1 circle, na? Half comma 0, radius is half. That means overall distance is 1. Half is here. So this is the center and radius is also half. This side half, this side half. So ultimately you get this one. So this is R is equal to 1 circle. What is this? R is equal to infinity circle. 1 comma 0 is the center. That means this is gamma R is 1 and gamma I is 0. So gamma R is 1 means this one, and this is the 1 comma 0 location. So then you draw a circle of radius 0. That means that is a point actually. So this is that point. For this point, radius is infinity. Infinity means radius infinity means open circuit. That is this is called POC, point of open circuit. So on this circle, everywhere R is 0 except this location. Except this location. So on the circle, everywhere at any location on the circle, R is 0, small r, except at this location. At this location, small r is equal to infinity because center 1 comma 0, radius 0. Radius 0 means that is point. So this is that location. This is later on we will see point of open circuit. In this way, infinity values possible for the small r, then you will get infinity number of circles. So Smith chart will have like this so many circles. For each circle, R value will be mentioned, smaller value. That is normalized resistance. Now in examination, they have given this and like this they have given in examination in Smith chart, and these circles represent option A constant R circles, option B constant X circles, like that they have asked. Then answer is constant R circles. You remember the shape. Actually studying means exam preparation means whatever you are studying, you observe deeply. For example, you study this one, then immediately you have to question yourself in examination how they can ask question. ये पढ़ने के समय में आप दिमाग के अंदर क्वेश्चन लगाना है, ये एग्जाम में कैसे दे सकता है, ऐसा क्वेश्चन आपको दिमाग को पूछेंगे, आपका दिमाग ज़्यादा ऑब्जर्व करते रहता है, वो आसान से एग्जाम में देखेंगे ना, वो आसान से पहचान सकता है. Now let us go to the constant constant X circles. Students, constant X circles have center 1 comma 1 by X and radius 1 by X. So you take here X value, okay, then here center, that is 1 comma 1 by X, and that is nothing but gamma R, gamma I. Then this is radius is 1 by X. Okay. You take X is equal to 0, X is equal to half, and X is equal to 1 dash 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 dash, X is equal to infinity. Okay, that means you can take so many values. So when X is equal to 0 now, students, here 1 comma 1 by 0 is infinity, and 1 by 0 means that is what you say, infinity is the radius. So X is equal to plus 0 I have substituted, so center is plus infinity, and this is the radius can never be positive negative, so that is infinity. X is equal to plus half I have substituted now, plus half I have substituted, then 1 comma plus 2 I will get center, and radius is what do you say, 1 by 2 means 2 I will get. So X is equal to plus 1 I am substituting, plus 1 means 1 comma 1 by plus 1 is 1 comma plus 1 I get. So radius is 1 I will get. So I will substitute plus infinity, then 1 divided by plus infinity means you will get plus 0. So 1 comma plus 0. and infinity 1 by infinity is 0 radius. Okay. Now you students know that x value varied from minus infinity to 0 and 0 to infinity. I have taken some values between 0 and infinity. Now I have to take some values between minus infinity and 0. So that is why I will take plus or minus. So x is equal to plus or minus 0. So plus minus 0. Then you get here plus minus infinity. And radius can never be negative. That is always positive. So plus minus. So here also plus minus, plus minus, plus minus, plus minus. Here also plus minus. But radius is always positive. Now let us draw the circles by taking this one is gamma r, and this is gamma I, and this one is minus gamma I, and this one is minus gamma r. Okay. Now this unit circle you have to draw here. This is unit circle, and this is gamma r square plus gamma I square is equal to 1 unit circle. So let us draw from the bottom side, students. X equal to plus infinity circle is nothing but 1 comma 0 center. That means this is 1, and 0 means height is 0. 1 comma 0 center, and radius is 0 means that is a point. So anyway, for time being I am removing this because I want to write something here. So this one is actually x is equal to infinity. X is equal to infinity, and plus minus infinity also this one, plus minus infinity. That means I was telling you this is the open circuit point actually. Okay. Now I will draw one line like this, passing through this point. This one, passing through this point. Like this. On this line, I will mention here like this. This is 1, and this is also 1. This is 1 comma 1 point. And if I mention here like this is actually this value is 1, and this gamma I is minus 1 here, that one. X is equal to plus 1 I put, 1 comma plus 1. 1 comma plus 1 means this one, that is the center, and radius is 1. So from here to here distance is 1. From here to here distance is 1. That means that circle passes through this point and this point. It should be going like this. It should be going like this. The circle goes like this. So here there is one circle. It is like this. Center is 1 comma 1, and radius is 1 here. From here to here to here 1, and this will be going like this. Like this it goes actually circle, and it is a little bit bend this like this. Like this it goes like this, students. But outside this unity circle we are not bothered about that shape and all, so don't bother about that, leave it, छोड़ दीजिए उसको ध्यान नहीं देना है, ठीक है. So this is x is equal to, I will draw here x equal to plus 1 circle this is, and if I put x equal to minus 1, 1 comma minus 1 is the center, this one 1 comma minus 1 is the center, and radius is 1. So downside it goes like this, and it goes through this. Okay, and if you want bend you can bend, no problem, circle jaisa feeling aane ka hai. So this is that line, and it will be going like this, student, like this. But outside the unity circle, whatever shape we are not bothered. So this is x is equal to minus 1 circle, students, x equal to minus 1. Okay, that is why top side plus jx circles are there, because you will have this in jx, r plus jx. So top side plus jx, bottom side minus jx. Top side plus jx means that is inductive part of the impedance, minus jx means capacitive part of the impedance, bottom side. Now here if you take x equal to plus half, then 1 comma plus 2 is the center. That means this much height approximately here is the center, and radius is 2. Radius 2 means here to here distance is 2 only, but that will be going like this. ऐसा जाएगा, ऐसा जाएगा. But outside we are not bothered. So it goes like this. ऐसा जाता रहता है ऐसा. So x is equal to, this one is x equal to plus 2, half circle, na? Half circle, right? And similarly, you put minus half, 1 comma minus 2, bottom side here it comes, it will be going like this. Exactly student, exactly रा करना, इसको इतना हाइट में ना ये है, ऐसा इधर जाना है, वो ऐसा जाना है, वो ठीक है, ऐसा जाएगा वो. So x is equal to minus half, that is okay, and x equal to plus 0 you take, plus 0, then 1 comma infinity, either 1 है, infinity matlab it go to infinity height and radius is infinity. So what is a circle of infinity radius? That is a straight line. So that straight line is here. I am using blue ink here. That straight line going like this, that goes. And x equal to minus infinity, once again that goes just downside this horizontal line. So this is actually x is equal to, what do you say, 0, plus or minus 0. So plus or minus 0 doesn't matter, plus or minus 0 means 0 only. So dear students, this is a straight line having infinity radius, it goes up to infinity, straight line of infinity radius. So now you have to answer the question, on this line, at any location x value is 0 only. On this line at any location x value is 0 only. So at this location x value is how much? At this location also x value is 0. So that is why here x value 0 and here r value 0. So that is 0 plus j0, that is short circuit point if you supercompose both of them. Then on this line at every location x value is 0, except at this location at the beginning I wrote this is x equal to plus or minus infinity. On this line at every location x value is 0 except at this location. So at this location in this circle you see r value 0, here x value plus or minus infinity. So this is infinity plus or minus j infinity circle, this one, this is open circuit point location, that is. So in examination, which of the following shape shows the constant x circles? You remember this shape, that is. Okay. Now what is Smith chart? So this okay, Smith chart is superimposition of constant r comma x circles onto gamma r and gamma I plane within unit circle. Okay. So here let us draw that. You write this one. I am going to rub that. If I need some place, I will erase that. उसको निकाल दूंगा मैं. So here this is gamma r, this is gamma I, and this one is minus gamma I. So this one is gamma r minus of. Okay. You take the unity circle. Now I can use same ink. That is unity circle. This side 1 radius, here also 1 radius, 1 radius, 1 radius. So this is r is equal to 0 circle. Yes, no, first one r is equal to 0. Next comes r is equal to half circle, like this. R is equal to half. Next comes here r is equal to 1 circle, like this. Next you go to the constant x circles. So if you draw here like this and you draw here like this, approximately this one and this one should be same. So थोड़ा सा स्मूथन कर लो इसको, चलेगा ऐसा. तो सर्किल शेप आना है थोड़ा सा, चलने तो कोई टेंशन नहीं है. Now here this one, this is actually, you see here, this one is x is equal to 0 circle, and this one is x is equal to plus half, and this one is x is equal to minus half. Dear students, reduce the place utilized. So x is equal to minus half, this is x is equal to plus half. X is equal to plus or minus 0 will be there here only. Next, x is equal to 1, minus 1 circle is here. X is equal to minus 1 circle is going here. And similarly, x is equal to plus 1 circle will be going here like this. Okay. So, now smooth on that one like this. Okay. This is x is equal to plus 1 circle. Now, what is this? Can you tell me, dear students, this location? At this location, small z is equal to r plus or minus jx. So, small z is equal to, on this circle at any location r value is 0, except at this location I have told you. So here you can see, here at this location r value is infinity, and at this location x value is plus or minus infinity. So infinity plus or minus j infinity, students. So infinity plus or minus j infinity. Then can you tell me, students, at this location, I will do some here. First one, z is equal to r plus or minus jx, that is equal to infinity plus or minus j infinity. That means capital Z divided by z naught. This is what do you say, infinity divided by infinity, and you multiply with infinity into z naught, infinity only. So ultimately z is equal to infinity j infinity you got. Then if impedance is infinity, ZL minus z naught, ZL plus z naught. That means it is open circuit, dear students. For open circuit, no, already you know, maybe for open circuit or maybe for short circuit, SWR you get infinity, student. So this is called P. P means point. O means open circuit. At this location, SWR is equal to infinity. Because at open circuit, otherwise already I told you, see, I told you Smith chart is nothing but mathematical equations only. For example, previously I told you case 1, I have taken ZL infinity, and then gamma L is equal to, I got you can see 1. For short circuit also I got -1. Then modulus of gamma for short circuit and open circuit is 1. SWR infinity I wrote there. The same theory is discussed here in the form of picture. That's it. ये स्मिथ चार्ट मतलब कोई भूत जैसा नहीं है. So this came from equations only. Okay. So this is one discussion. Now for this location, if you see here, small z is equal to r plus or minus jx, that is normalized impedance is equal to normalized resistance plus or minus j into normalized reactance, that is r value 0 plus or minus j 0. So here you can see r value 0 here and here x value 0. So at this location both are 0. So that is why it's called a point of short circuit. So for short circuit also, students, what do you say, that is plus or minus jx 0 plus or minus j 0. So this is capital Z by Z naught 0 plus or minus j 0. Capital Z is equal to Z naught 0. So 0 plus or minus j 0. So it is short circuit impedance. Now SWR is once again infinity only for this also. So here also SWR is actually infinity. At this location also infinity. Now can you tell me what is maybe I will put some location A, B, C, D like that. Okay, I will put A location. This one, na, center. At A location, because no place no to write there. ये थोड़ा सा ऐसा जाना पड़ेगा. ठीक है. I am not bothered about this exact circle shape, student. Don't worry. Right. So this A location na, at point A, on that Smith chart, can you tell me small z is equal to r plus or minus jx? Or otherwise I will do one thing, students, so that you can easily understand. At point A, gamma is equal to gamma real plus minus j gamma imaginary. So can you tell me what is gamma r here? Here 0, because this is center. You go like this, gamma r becomes 1. You go like this, gamma r becomes minus 1. But magnitude is 1 only. So you go, this is gamma I 0. You go like this, gamma I is 1 here. You go like this, gamma is minus 1 here. But magnitude of gamma is 1 only. So at the center, gamma r 0 and what do you say, gamma I 0. That means that implies modulus of gamma is 0. Then SWR is equal to 1 plus mod gamma 1 minus mod gamma 1. So at A location, SWR is actually 1, student, at A location. That is matched location, that is. So that is matched location. So on Smith chart, point A is impedance matched location. Impedance matched location. So on Smith chart at point A is impedance matched location, where SWR is 1. So anyway, some more points I will tell you. For example, on this Smith chart, this is location B, let us say, and this is location C, let us say. You are going like this. Location B to C, you are going like this. That means you are going on constant resistance circle. Resistance is series parameter. And if you go upwards like this, this is here x value 0. So this is J0. Here x value is J 1 by 2. Here x value is J1. So that means like this you go, here this is plus Jx. and that means you are going upwards means inductance value should be increased. Inductance is also series parameter. So now they ask question, objective question, they give B, C location Smith chart. So on the Smith chart, going from B to C location indicates option A, B, C, D. Answer, adding impedance in series, adding inductance in series with impedance. Because you go like this means plus Jx, positive reactance is for inductor. So that means you are increasing the inductance. So on the Smith chart, going from B location to C location is nothing but adding inductance in series with the impedance. Because inductance and the going like this means that is plus Jx and on the constant R circle. So resistance and inductance, they are series parameters. That is why in series with the impedance you say. So next, upper half of this Smith chart is plus Jx. What is lower half? Like this you go, then here this line is plus J0, this line is minus Jx. If you write now, then this is minus J by 2, this is minus J1, like that it is going, so it is minus Jx. So upper half is plus Jx, lower half is minus Jx. Next point, wherever, for example, you take this one, this is constant R circle, this is constant X circle. Wherever they meet na, at meeting angle will be 90 degrees exactly. Meeting angle will be 90 degrees exactly, 90 degrees. Only at that location you have to see, not every location. Wherever constant R and constant X circles join, at the location, at the joining location, the angle is 90 degrees. That is why one point is there, that I will tell all the points, I will write all the points. Constant X and constant R circles are orthogonal to each other, otherwise they meet, otherwise they join at 90 degrees angle. Next, all the constant X and constant R circles goes through this location, this gamma R is equal to 1 and gamma I is equal to 0. This location is gamma R comma gamma I location. All are going through this one. So that is also one point. All the constant R circles and constant X circles passes through the point 1 comma 0, where 1 is gamma R, gamma I is 0 actually. Actually on the Smith chart, na, for example, if you take here short circuit as 0 distance, then you come here, na, actually I told you anywhere impedance is 0, then that is short circuit. Again from that location you come, what I am telling is, students, so let us say on the transmission line here impedance is 0. Impedance is 0. That means on the transmission line impedance is 0, here means it is a short circuit. That means on the Smith chart you are here. Then you are going like this. You are going like this. That means you are going like this. And again you come for lambda by 2 distance here. Again you get impedance 0. That means on the Smith chart again when you are getting, for example, you are here means you are here, because 0 impedance short circuit. That means on the Smith chart you are here. You increase the distance, then you are going like this. When you come to short circuit again after lambda by 2, that means you come to short circuit here again after lambda by 2. That means on the Smith chart overall length is lambda by 2 actually. So if you see Smith chart diagram, they give around the Smith chart, they give wavelengths, and they give angles of reflection coefficients, and they give angles of transmission coefficients also. But giving one parameter is sufficient to solve any problem. Anyway, now I am using this place here little bit, so I will use this place. ये जगह यूज करेंगे इधर. You tell me one simple, I will ask one simple question, give me the answer. For example, I have taken one transmission line here like this. I have taken one transmission line like this. Okay. Now I am asking questions, you have to answer, students, because if you answer then only you can understand. Now whatever questions I am asking, you know the answers also. That is why you have to listen the question and answer. Okay. Minus gamma r. Tell me, ZL0 means what? ZL0 means what? Short circuit. Where? At the load. ZL0 means short circuit. Where? At the load. Then can you show me that location on the Smith chart? Yes, you can show. This is the short circuit location. This is the short circuit location. That means on the Smith chart, this location gives load, short circuited load. Okay. Now for load D is equal to 0. What is the impedance at D distance? Impedance at D distance for short circuit case. Then answer is J Z0 tan beta D. Already you know this. Impedance at any distance on the transmission line for short circuit line is ZSC is equal to J Z0 tan beta D at D distance impedance. If total length is L, then you put L here, you get input impedance. So here you see this one, you will understand. At D means at D means this formula gives impedance at D distance from load end for short circuit case. Then for example, D is equal to 0 means D0 means at load, right now. D0 short circuit is there. That means here is the short circuit on Smith chart. That means load location. Now load location on the Smith chart is this one. This one. Load location. Now I am substituting D is equal to lambda by 8. Then what do you mean? You are coming lambda by 8 meters distance towards the generator. So here is the generator, signal generator, plus minus. So what is this? This is generator. And D0 means at load. D is equal to lambda by 8 means you are coming from load towards generator, you are coming. Now that implies beta into D is equal to, beta is 2 pi by lambda, D is lambda by 8. So lambda lambda cancel, you get pi by 4. Now ZSC at D is equal to lambda by 8 distance. I will write this also. ZSC at D is equal to 0 distance is 0, short circuit. So that is this location. Now ZSC at D is equal to lambda by 8 is equal to J Z0 tan pi by 4. That means J Z0. Z0 is actually real, that is J R0. So that is nothing but J into root L by C. No, you studied na. For lossless line, Z0 is equal to R0, R0 is equal to root L by C. So this is plus Jx or minus Jx, this one. So this is nothing but positive reactance, that is. So that means positive reactance is coming for top side or bottom side? Top side. That means on the transmission line, you are going from load towards the generator, means your impedance is going from 0 to positive reactance side. Then here you are going on the Smith chart, you are going like this, because positive reactance is coming this side. That means that's why in the books they write this is load location, and you go like this, then it is called towards generator movement, like this, towards generator, that is. So for example, here you go for approximately, I will do one thing, 0, okay, lambda by 8, 2 times lambda by 8, 3 times lambda by 8, and 4 times lambda by 8. 4 times lambda by 8 is what, students? Lambda by 2. That means distance 0 means this location. Lambda by 8 means this location. 2 lambda by 8 means this location. 3 lambda by 8 means this location. And 4 lambda by 8 means lambda by 2, that is again this location on this Smith chart. That means you are at load means D0 means you are here. D is equal to lambda by 8 means on this Smith chart you are here, but on the transmission line you are at D by 8 distance. And like that, etc. students. That is the meaning. So, I am going to write the conclusions now. I will write the conclusions here. Let us write the points. So, the first point is first point, upper half of Smith chart gives plus Jx, then lower half gives minus Jx. This is inductive, this is capacitive. Then constant R, comma, constant X circles meet at 90 degrees or otherwise orthogonal to each other. Orthogonal to each other. That means orthogonal to each other means 90 degrees only. Constant R, comma, all I will write. All constant R, comma, constant X circles passes through gamma R, comma, gamma I is equal to 1, comma 0 point. They passes through this point. Okay. Next, on the Smith chart, there it is shown, no? Going from point B to C indicates adding inductance in series with impedance. Next one, at POC, that means point of open circuit, that is at POC, that means point of open circuit. V maximum comma voltage maximum location that is, and impedance maximum comma I minimum are present, and at that location already you know SWR is equal to infinity. Next, at PSC, that means what is that? Point of short circuit. Point of short circuit. At PSC, voltage is minimum. We have studied these things in theory, no student. Representing theory in diagram form is nothing but Smith chart only. From equations only you got that one, na? So V minimum and Z minimum comma I maximum are present. So already you know that at these two locations SWR is infinity. Already I wrote there SWR infinity at those locations. Okay. And around the Smith chart, wave length comma angle of reflection coefficient and angle of transmission coefficient, are given. Total length around Smith chart is lambda by 2, because for lambda by 2 length all parameters repeat, that's why. So if you draw a circle, student, for circle what is the total angle? 360 degrees, na? So angle is 360 degrees, but here in the Smith chart it is in terms of wavelengths lambda by 2. That means here lambda represents 360 into 720, right? Na 120, 600, 120. Right. So total length around the Smith chart represents total length lambda by 2. But in terms of degrees, you see, now students, if you draw any circle, then automatically overall angle is 360. So now lambda represents 720. Okay. So these many points you have to revise. Now you can solve some one thing I want to tell you, students. You see here before removing this I will tell you. Now they give Smith chart like this. Somewhere here or maybe here इधर उधर एक जगह में कोने में they give Z0 is equal to, इधर कोने में देता है, इधर उधर दे देता है, और Z0 is equal to 50 ohms देता है, sometimes 75 देता है. Generally transmission line characteristic impedance is around 75 like that. वो दे दिया, वो 50 दे दिया. Now this location D, so this is location D I am putting. Find impedance at location D. Then what you do? At location D, small z is equal to R plus jx Now dear students, here this circle is r is equal to half circle, and it is going like this, means that is x is equal to plus 1 circle. Now you know that small z is equal to capital Z by z naught is equal to half plus j1. Now z is equal to z naught is 50, 50 into half, that is 25 plus j 50 ohm. In two ways, they can write here half plus j1, or otherwise they can write here 25 plus j50, they can write, both are correct. So students, they write at this location, इस जगह में half plus j1 लिख दिया, मतलब वो नॉर्मलाइज्ड इम्पीडेंस है. इस जगह में वो लोग 25 प्लस j50 लिख दिया. 25 प्लस j50 मतलब वो इम्पीडेंस है. दोनों सही है, दोनों सही है. सो इस तरीका में आप लोग लोकेशन टू लोकेशन नॉर्मलाइज्ड इम्पीडेंस फाइंड कर सकता है. Then if you know normalized impedance, then you can find impedance by multiplying the normalized impedance with characteristic impedance, students. Okay, right. So dear students, now let us write one note. Transmission matrix of the transmission line in steady state. So in steady state we are discussing, not transient state. I will tell you transient state also, one diagram. In steady state, first I will draw the diagram. This is the Smith chart. Z0 is characteristic, no Smith chart खत्म हो गया, ये है transmission line. So this transmission line total length is L, na? L is the length of the transmission line. Okay. Now here load is there. Load. This is called IL. This is called here, or otherwise here, doesn't matter student. इधर भी लिखो, कोई टेंशन नहीं है. Plus minus VL. Here also VL is there. That is nothing but I will write here V2. So here V2 is nothing but VL, students. That is VL is equal to V2. Okay. I will write this as a I2 at the load. So IL is equal to minus I2. Next, I have connected here some generator. It is internal impedance and it is voltage of the generator, right? Now here voltage is V1 and here like this current is I1. So this is port 1 and this is port 2. Here V2, no, for example V2 I will write, student, V2 is equal to V plus e power minus gamma L, V minus e power plus gamma L. This is total voltage at load, incident voltage plus reflected voltage, total voltage at load. Similarly, this is total current at load. This is not reflected current, total current at load. So for example, na, what is IL? Total current at load. Then opposite sign is given for that. So IL is equal to minus I2 here. IL is like this, that is nothing but minus I2. Okay. IL is minus I2. I will write them. So here V1 is total voltage, that means incident plus reflected, that is the meaning. Total voltage at port 1 in steady state, वो देता है in steady state में करके, in the steady state, discussion is steady state. Steady state मतलब at the beginning when you turn on this, na, for few microseconds, few nanoseconds, transients exist on the transmission line that I will explain you later on. So after finishing a few microseconds, after finishing 100 nanoseconds or 200 nanoseconds, it depends on transmission line to transmission line, then comes the steady state. Till now we have discussed every equation in steady state only, not in the transient state. We have not discussed transient state. Transient state is not that much important here. For example, you switch on the fan, switch on the fan, then for a few seconds fan speed is less, but we don't want that, and after few seconds it picks up constant speed, then we get the cold air. That's what we want. Similarly here also, transients energy is not transferred. That is only for analysis purpose we use the transient analysis, but always we send the power in steady state only. So V1 is total voltage, that means incident plus reflected voltage at port 1. Similarly, I1 is actually total current. So total current at port 1, and V2 is total voltage at port 2, and I1 is nothing but total I2 na. So I2 is total current at port 2 students. Now you know that this is V1, I1 is equal to ABCD transmission matrix, then V2 minus I2. Okay, they give V2 I2 like this, but they write here minus I2. So that minus I2 means this one, that is nothing but IL only. Okay, now that is V1 I1 is equal to here cos H gamma L, next Z0 sin H gamma L, total length na student, input to output we are linking, so we have to take total length L, then sin H gamma L divided by Z0, then this is cos H gamma L. I wrote the voltage and current equations, from that only you get this one. So here V2 minus I2. So this formula is in what do you say? This is used for general transmission line. For general transmission line, where gamma is equal to R plus j omega L G plus j omega C, that is nothing but alpha plus j beta, and Z0 is equal to root of R plus j omega L G plus j omega C actually. Next, for lossless transmission line, gamma is equal to j omega root LC, that is nothing but j beta, and Z0 is equal to root L by C, that is nothing but R0. So in that case, this becomes V1 I1 is equal to, this is cos beta L, because cos H j beta L becomes cos beta L, and sin H gamma is j beta L, sin H j beta L becomes j sin beta L. So you get j Z0 sin beta L, and this one is j sin beta L divided by Z0. This is cos beta L, and now this is V2 minus I2. So this is for steady state actually. And of course, uh, in the transmission line where V2 is equal to VL, that means load voltage, and minus I2 is equal to IL. For example, anywhere they give VL and IL, then substitute here VL, IL, then you get input side voltage and current. If they give V1 and I1, then you will get V2, VL and IL by taking inverse of this matrix. You remember one thing, automatically no need to remember the inverse. Now, this is a note, this is over now. Now, let us solve some questions. So, this is a question is there here. Consider a 300 ohm quarter wave long. So, consider a 300 ohm means Z0 is equal to 300 ohm given, and quarter wave long transmission line, that means length is equal to lambda by 4 is given, and frequency is 1 gigahertz given at 1 gigahertz transmission line as shown in figure. It is connected to a voltage. Actually in the diagram everything is given, student, so I am drawing the diagram. So this is the source having voltage V is equal to 10 volt, and the internal impedance of this is ZG is equal to 50 ohm. Okay, so this is given like this, and the characteristic impedance is 300 ohm, and the load is open circuit, nothing is there. Now length of the transmission line is actually lambda by 4. This is open and is left open circuited at other end. One end this is connected voltage 10 volts having internal impedance 50 ohm. Other end is open circuit is there. The magnitude of the voltage at the open circuit end of the line is. So that means magnitude of the voltage is asked, mod VL is asked, open end. So this is steady state. Now for your convenience, I am drawing this. First of all, what I do, I will calculate input impedance of lambda by 4 transmission line. That is nothing but Z0 square by what do you say, Z0 square by ZL. Okay. So Z0 square is 300 square divided by ZL is what, students? ZL is equal to open circuit, no? So ZL is equal to infinity. So you get Z in of lambda by 4 is 0. That means now I am drawing the equivalent circuit. So there is some voltage source. That voltage is generator voltage is V volts, and then there is an internal impedance ZG. How much? 50 ohm. Now this is connected to the transmission line of total length. इधर से शुरू होता है, ये सब है ना बॉक्स, ये बॉक्स में है ये. Now this is transmission line. I am drawing here the length of the transmission line is equal to L is equal to lambda by 4 here to here. So इधर तक वो है. Now what is the input impedance here of this 0? 0 means what? Short circuit. So input impedance is short circuit. Now here you will have like this I2, and load voltage is there here, and that minus I2 is nothing but IL. Already you know that. So ZL is equal to 300. Now can you tell me, here it is short circuited, that means what do I okay, I will write here. I will do one thing. This is actually V1, student, voltage here is. Now here Z in of lambda by 4 is equal to 0. Whenever there is a short circuit, it is better I will write here, students, because you will be confused. I am writing here, you see. ZG is equal to 50 ohm, separate diagram, na? Vg is equal to 10 ohm, 10 volt. Now here at the input, Z in of lambda by 4 is equal to 0. That means it is short circuit. Now whatever voltage is there here, that is called V1. So now across the short circuit, what voltage will be there, student? 0. Now whatever current is going here now, that is called I1, student. Here I1. I1. So here whatever current is there, that is called I1 current. Now total length is this much, na? Okay. I1 current is what, student? Here I1 is equal to Vg divided by Zg plus Z in of lambda by 4. So that is 10 divided by 50 plus 0. So you get 1 by 5 ampere. That means in this question V1 is 0, I1 is 1 by 5 ampere. You have to find I2 and VL and IL you find. So this one only equation, right? Actually one thing I want to tell you, Z0 is real. Z0 is real means it should be L by C. So if L and C only is there in Z0 means R and G 0, that is a lossless transmission line. So you can decide that it is a lossless transmission line. Anyway, now can you calculate beta L here? Beta into L? Beta into L. 2 pi by lambda. L length of this transmission line is lambda by 4. So lambda lambda gone. You get pi by 2. So dear students, I will write the V1 I1 is equal to then cos of beta L means what, student? Pi by 2. Next J Z0 is how much given? 300. Z0 is 300. Sin pi by 2. Next J sin pi by 2. I am using this equation, student, divided by 300 cos of pi by 2, then V2 minus of I2. So here I wrote V2 is nothing but VL minus I2 is nothing but IL. So now what I do? V2 IL, students, in place of minus I2 IL I wrote, then what is this? 0. What is this? J 300. This one J by 300. This one 0. So I am writing this, I am sending this that side, that means whole inverse. Then what is V1? 0. What is I1? 1 by 5. What is inverse of this matrix? Interchange them. 1 by AD minus BC, A into D minus B into C. Gone 300 or 300. J square is minus 1. That gives you get 1, students. Next, interchange them. 0 0. Next, minus of J 300 minus J 300. Interchanged them. So this is 0, 1 by 5. This is 1 na. Okay. Now V2 I2 VL IL. VL IL. VL IL. Because V2 is equal to VL minus I2 is nothing but IL. Okay. Now this multiplied with this 0 into 0. This is minus J 300 by 5, student. It is 60 na. Yeah, 60. Then this multiplied with this 0. This multiplied with 0. So students, you got VL is equal to minus J60 and IL is equal to 0. Now that fellow asked what is modulus of VL at open circuit end, what is modulus of VL? Answer is 60 volt. If they ask what is modulus of IL, 0, because that is open circuit, no students. That is why they don't ask IL, it is meaningless. If they ask IL, without solving, answer is 0 because that is open circuit. Okay, next. Next one. Question number 22. A uniform transmission line characteristic impedance 100 ohm and feeding a purely resistive load uses single stub matching. The stub is placed at a distance d from the load. The VSWR on the length d and stub itself is saying a diagram is like this. So he is saying a uniform transmission line of characteristic impedance Z0 is equal to 100 ohm and feeding a purely resistive load. So ZL is equal to 500 ohm. Uses a single stub matching. The stub is placed at a d distance from load. So here load d0 and it is a d distance from load. Like this stub is there. So that is actually what do you say, short circuit stub. So this is stub. Okay. The VSWR on the length d, that means this length, student. Length d and the stub itself will be. So anyway, VSWR of stub is infinity. Next here SWR or otherwise VSWR is equal to, first gamma L is ZL minus Z0 divided by ZL plus Z0. Then 1 plus mod gamma L by 1 minus mod gamma L is VSWR. But no need to use that formula, shortcut formula is there. If ZL and Z0 are real, then SWR is equal to ZL by Z0. So SWR here is 500 by 100, that is equal to, what do you say, 5. So answer 5 comma infinity respectively. So option is D. Next question. A 75 minus J40 ohm load is connected to a coaxial line of characteristic impedance 75 ohm at 6 megahertz. The load matching on the line can be accomplished by connecting. Actually, it is a complex load, no student. A short circuited stub at a specific distance from the load end. That is the answer. So, question number 23. A 75 minus J40 ohm load is connected to a coaxial cable. Simply it is called coax. Coax means coaxial cable of Z0 characteristic impedance 75 ohm at some frequency 6 megahertz. The load matching on the line can be accomplished by connecting. Answer is connecting a short circuited stub at a specific distance from the load. So this is nothing but a single step matching. I told no, whenever there is a complex load, then matching is done. This is load no complex actually. Then matching is done easily using the single stub. Then that single stub is to be placed at LS distance from the load. That is called specific distance. That LS is called specific distance. Okay. Next. Which one of the following statements is correct? Which one of the following statements is correct? Short circuit stubs are preferred to open circuit stubs because later means open circuit stub are liable to radiate energy. So that is the answer. Na? Already I told you in the statement. So short circuited stubs are preferred to open circuited stub because open circuited stubs are liable to radiate. So that is in option C. That is the answer. Next question. A quarter wave transformer made of air-filled coaxial line. That means coaxial cable is used as a quarter wave transformer. That means radius is A actually. Then like this it is like this. Then this one is radius B, and anyway this is the coaxial cable, and this one is also conductor. So here dear students is used to, once again I am reading, a quarter wave transformer made of air filled, this is air actually, so this is air. So air filled coaxial line, this is lambda by 4. A quarter wave transformer made of air filled coaxial line matches two transmission lines of characteristic impedances 50 ohms and 72 ohms respectively. Similarly, here one more quarter wave transformer is there, then the characteristic impedance of that is actually for one of the transmission line 72 ohm, other one is 50 ohm. Okay. So here you can say one transmission line is there like this, maybe transmission line two-way or otherwise another coaxial cable. One is having a 72 ohm characteristic impedance, other one is having 50 ohm. One side is 70, other side is what do you say, 50 ohm. Okay, 50 ohm and 72 ohm respectively. The inner conductor of coaxial line is made up of 10 mm diameter. So inner one, that means he has given 2a is equal to 10 mm diameter. This is a is radius, 2a is diameter, students. What should be the diameter of the outer conductor approximately? That means b is radius, totally this is b is radius, 2b is diameter. You have to find that one. A very simple question. Now the characteristic impedance of this is called as ZQ. Students, if the output impedance of this is equal to 72, then matching is done here. The input impedance of this lambda by 4 coaxial cable is 50, then matching is done here. So now students, for matching purpose, Z1 into Z2 is equal to ZQ square. Now ZQ square is equal to ZQ is equal to root of Z1 into Z2. Here output impedance Z2 is equal to 72 होना है, then only matching is done. Then input impedance of this is equal to 50, then only matching is done here. So if input impedance is 50 na, then this equal matching is done. If output impedance is 72 na, then this matching is done. Now here ZQ is equal to root of Z1 into Z2. Now for the so ZQ is equal to root of 50 into 72. Now you know what is the characteristic impedance of the coaxial cable, lossless coaxial cable? 60 divided by root epsilon r ln B by A base E. So here B by A is there, and if you want this is B by A, numerator also you can multiply with 2, denominator also you can multiply with 2, no issue. So this is root of 50 into 72, and for air field na, it is air field, it is given, then root epsilon r, okay, you write 60 by root 1, one more step we will write 2b, we need 2a is given as 10 mm, so 10 into 10 to the power minus 3, that is root of 50 into 72. You complete this mathematics, you get 27, it seems 27 mm आ जाएगा आंसर. ये कंप्लीट करो आप लोग. सो एयर मीडियम है इसलिए 1 लिया है. देन 2b, एक्चुअली b by a, 2 you can multiply, 2a is given. Do this. Next, this question number 26. Here one Smith chart is given. For example, in option A, impedance is given as 10 plus j10 student. For this, normalized impedance is equal to 10 plus j10 divided by what do you say? Normalized impedance definition is what? Impedance by characteristic impedance. So 10 plus j10 divided by somewhere above the Smith chart na Z0 50 given. Above the Smith chart Z0 is equal to 50 given. So 50 you take, that is equal to here 0.2 plus j 0.2, that is nothing but r plus this one na, this one small z is equal to r plus jx, that is 0.2 plus j 0.2. That means r where this impedance should be located on the Smith chart, this impedance should be located on the Smith chart wherever r is equal to 0.2 circle and x is equal to 0.2 circle join. So that is correct actually. If you see there, if you see 10 plus j10 impedance on the Smith chart is located at the intersection of r is equal to 0.2 comma x is equal to 0.2 सर्किल्स. इंटरसेक्शन मीन्स दोनों लोग मिलने का जगह में है, इसलिए वो सही है, वो ऑप्शन सही है, सही लोकेशन में लगाया. सो इस तरीका में फॉर बी ऑप्शन के लिए z इज इक्वल टू 50 प्लस j50 गिवन. So normalized impedance z minus z0 is equal to 50 plus j50 divided by 50, and that is 1 plus j1. So r is equal to 1, x is equal to 1. So this 50 plus j50 is located on the Smith chart wherever constant r circle 1, constant x circle 1 join. So that is also correct answer. So B, C also correct answer. This can be asked in multi-select questions also. Which one of the following locations are correctly represented on the Smith chart? A, B, C are correct. Then D option is wrong actually. In D option, So impedance is given as 25 minus of J50. So normally impedance is equal to capital Z by Z0. 25 minus J50 divided by Z0 is 50. So now that is equal to 0.5 minus J1. So R plus or minus Jx is equal to 0.5 minus J1. Now you compare that one here. R is equal to 0.5 and X is equal to minus 1. So it is wrongly located. So this location, this is wrongly located because they did not locate this point on the R is equal to 0.5 circle. No, that is wrongly rotated. That is why that is a wrong location. You can see the diagram is with you.